Hello guys, basically we have a question here from electromagnetic induction. According to the question, let me elaborate you the question. According to the question, a 10-meter wire is kept in the east-west direction and it is falling down with a speed of 5 meter per second perpendicular to the horizontal component of Earth's magnetic field, which is given as 0.30 into 10 to the power minus 4 Weber per meter square. Okay. And what we have to find is we have to find the momentary potential difference induced between the ends of the wire. Okay. What we have to find? We have to find momentary potential difference. Now let me tell you, according to the momentary potential difference, it is nothing but momentary potential difference means we have to find induced current. Now what is induced current? What we have to find? We have to find induced current. What is induced current? Induced current is nothing but the current produced by the fluctuation of magnetic flux or magnetic field. Induced current is nothing but a current which is produced by what? Changing in the magnetic flux or magnetic field. Whatever current which we will get now after the changes in magnetic field or in the magnetic flux, then whatever the current we will get now, that current is known as induced current. Means this current, basically induced current, how this current will form? This current will form from the changes of magnetic field or magnetic flux. Whenever magnetic field or magnetic flux change, no, the current which we will get, no, that current is known as induced current. Okay, so what we have to find? Nothing but we have to find momentary potential difference, which means we have to find the induced current or else EMF. Okay, electromagnetic force of that induced current, we have to find that. So according to the question, what it is given, that I was just telling you, elaborating you, what does momentary potential difference means. It means that what we have to find, you have to find the induced current produced by that electromagnetic force. Got it? Now how we will find that induced current? Okay, so according to the question, what is given, that a 10-meter wire which is kept under east west direction. Suppose if we will take the direction, this is east, this is west, this is north, and this is south. Okay, so the in initial time the wire was kept under east west direction. Means the wire was kept under east west direction, means it was kept horizontally. Okay, this is 10 meter. If this is A and this is B, wire was kept like this. And now what happened after that? It is falling down with a speed of 5 meter per second. Mean to say that wire was kept in this direction. If wire was kept in this direction, it is, after that what happened? It started falling down. It started falling down with a speed of 5 meter per second. Means after some time what happened? The wire starts falling down in vertical direction. Means same wire, this AB, which was in the horizontal direction, comes under vertical direction with a speed of 5 meter per second. Okay, so mean to say that the same component, same wire which is of 10-meter length, which was under east west direction, now comes down with a speed of 5 meter per second under what? Vertical direction. And how it comes under vertical direction, how we can show that? Because it is given here that when the wire was falling down with the speed of 5 meter per second, it is perpendicular to the horizontal component of Earth's magnetic field. Suppose this is the horizontal component of the Earth's magnetic field. This is the horizontal component. Suppose this is the horizontal component of the Earth's magnetic field. Then wire is where? Wire is always perpendicular to that Earth's magnetic field. Okay. Suppose this is the Earth magnetic field. This is the Earth magnetic field. So wire will be perpendicular to that Earth's magnetic field. Means this will be 90 degree. Mean to say that wire which is coming down now with the speed of 5 meter per second, this is perpendicular. Okay, so always remember that whenever motion of conductor, magnetic field and induced current are perpendicular to each other, whenever motion of conductor, magnetic field and induced current, middle finger shows that induced current, thumb shows that motion of conductor, and forefinger shows what? It shows magnetic field according to the Fleming's right hand rule. So whenever all these three components are perpendicular, what we use? We use the formula as E is equal to BVL. When we use this formula, this is what? This is the formula for calculating induced current of electromagnetic induction. Okay, So when we will use this formula, we will use this formula one only in the case whenever the motion of the conductor, that is this motion of the conductor, forefinger is magnetic field and thumb is the thumb is what? Thumb is the, sorry, pardon me, I am really very sorry. Actually, middle finger is the induced current, forefinger is that magnetic field, and thumb is what? Thumb is nothing but the motion of conductor. So whenever all these three components are perpendicular to each other, we use this formula, okay? Where B is what? B is nothing but B is known as magnetic field, okay? B is known as magnetic field. V is nothing but V is the velocity with which the motion of conductor is moving. Here, what was the velocity with which motion of conductor was moving? It was 5 meter per second. And what was the magnetic field given? As the magnetic field was given as 0.30 into 10 to the power minus 4. Okay, this was the magnetic field given. And what we have to, and what was the length? Length was 10 meter. Got it? Now, for finding, what we have to find? We have to find induced current, okay, in the electromagnetic induction. So we will directly put the formula, right? So by putting the formula, what we will get? Let me erase this. So by putting the formula, what we will get? We will get it as E is equal to BVL, where B is nothing but magnetic field, which is given as 0.30 into 10 to the power minus 4, and V is nothing but the velocity of the motion of conductor, which is given as 5 meter per second. L is nothing but the length of the conductor, which is given as 10 meter. So when we will calculate it, we will get it as 1.5 into 10 to the power minus 3 volt. So if you have to write it, means you can write it also, it is like that, 0.0015 volt. Now this comes under, now what we get it, we get the momentary potential difference, or we get the induced EMF. We get the induced EMF, that is 0.001 volt. Now suppose if they will ask the direction, mean to say if they will ask the direction of wire, means the direction of wire, direction of motion of the conductor. If they will ask the motion of the conductor, means what you will say? Mean to say, means suppose here it is completed, we have finded the induced current. Now if they will ask you that what is the direction, what is the direction of the wire which is going, means how you will find the direction? For finding direction, we can use two law. Either we can use Lenz law, or else what we can use, we can use Fleming's right hand thumb rule. So we know that the motion of conductor is, if we use Lenz law, means Lenz law is, this is the thumb which show the motion of the conductor, and this shows the direction. This forefinger, no, other forefinger which is like bended, this shows the direction, and this thumb shows the motion of conductor. So here motion of conductor was how the it was given here that it is falling down with the speed of 5 meter per second. Motion of conductor was downside, right? It was downside, no? So what will be the direction? What will be the direction of the wire? The direction of wire will be from west to east. Why? Because motion of conductor is going down, right? Motion of the conductor is going down. So what will be the direction? This forefinger will show the direction, and it is bending by what side? It is bending by clockwise. So direction will be from west to east. Mean to say that direction of the, if suppose they will ask you, means if suppose they will ask you the direction, means then only I am telling you. If suppose they will ask you the direction, means what will be the direction of that EMF? Sorry, not wire. What will be the direction of EMF? I am telling you about the direction of EMF, means that induced current direction. So how, what will be the direction? Direction will be from west to east. How it comes west to east? By Lenz law, or else you can use Fleming's right hand thumb rule. By Lenz law, how we get it? The direction, the motion of conductor was going down. Down means this forefinger which is bended, this shows the direction, and it is when the wire is falling down, the motion of conductor is clockwise, means from west side to east side. From west side to east side is the direction of EMF, induced EMF. The induced EMF came, no, 0.0015 volt. So what will be the direction of that EMF? That direction will be, it is not been asked, but I am telling you that suppose if they will ask the direction also, obviously they can ask, right? So the direction will be from west to east. How we find it out? We find it out with Lenz's law. Other law which we can find it out by Fleming's right hand rule. According to the Fleming's right hand rule, what does it say? It says that the middle finger, forefinger and the thumb, these three are perpendicular. And what does the middle finger state? The middle finger states that induced current which is producing or which has come. And what does the forefinger say? The forefinger state about the magnetic field. And what does the thumb state? Thumb state about the motion of the conductor. Okay, so if we will find out, we can find it out by Fleming's right hand thumb rule also. Motion of the conductor was how? It was downwards, right? Motion of the conductor was downwards and all three are perpendicular. So what will be the direction of induced current? It is coming from west to east, right? That's why it is west to east. Now direction, you know the EMF which is produced by the induced current, it is 0.000015 volt. And what is the direction? Direction is west to east. And suppose they will ask you, if direction is the additional, and suppose additionally they can ask you one more thing, is that in the same question they can ask you that which end of the wire will have higher potential. Means the wire has two end, right? A, B, this is 10 meter, this is 10 meter, right? Suppose they will ask you that which end of the wire will have higher potential, then always remember wire is coming down, right? Vertically downward from horizontal it is coming down. So whenever it will come down from horizontal part, always remember that the A position which is on the left side, which is coming from left to right side, that will have always the higher potential. Mean to say that here A will have A will have higher potential, higher potential than B. So what we have calculated, so if I summarize this thing, means how I will summarize it. Basically what was the question given? The question was given that a 10-meter wire is kept along east-west direction, that horizontal direction, east-west direction, this direction, okay? And now it is coming down with the speed of 5 meter per second, where magnetic field was given as 0.30 into 10 to the power minus 4 Weber meter. What we have to find? We have to find the momentary potential difference. What does momentary potential difference means? It means that we have to find the induced current in that EMF. Okay, so why we have to find induced current in the EMF? So whenever that motion of the conductor, a magnetic field and induced current, whenever these three components will be perpendicular to each other, what we find? We find induced current or else induced EMF. First of all, what is induced current? Induced current is the current produced by the changes in the magnetic field or in the magnetic flux. That current will called as induced current. And here what is this whole problem comes under motional EMF. Motional EMF mean to say whenever a conductor is in motion, no, whatever EMF we get, that EMF is known as motional EMF. And we know that the wire is in motion, right? From horizontal component it is coming vertical, it is coming downward vertically, okay? So the like the component of the vertical component is in motion, right? The wire from horizontal to vertical, so it is in motion, right? So we will call it as this topic, it will be called it as motional EMF. Motional EMF. Why we call it as motional EMF? Because whenever a conductor is in motion and whenever we find the electromagnetic induction or else the induced current, we called it as motional EMF. Whenever the conductor will be in motion, the EMF which will be generated is known as motional EMF. Okay. So how we find it, the EMF or the induced current? By directly the formula. The formula is E is equal to BVL, which is always perpendicular to each other, where B is magnetic field, V is the velocity, L is the length. Directly put the value and get the answer. Now from here the question is asked up to here, that what is the induced EMF, what is the momentary potential difference. Suppose if they will ask you the direction of that EMF, what you will do? You will find the direction by what? By Lenz's law. Lenz's law, or else by what? By Fleming's right hand thumb rule. Right hand thumb rule. Lenz's law means, Lenz's law is this one. The thumb indicate the motion of direction of the conductor and other forefinger indicate what? The direction of magnetic field. Okay. This shows that direction of the motion of conductor. Sorry, this is the thumb, right? The thumb shows you nothing but the direction of motion of the conductor, and this shows the direction of induced EMF. Okay, so here the direction was vertically downward, right? The wire was falling from horizontal to vertical component. No, the wire was falling downward, right? So wire component, wire was the conductor of the wire which is downward, means the thumb will become downward. And what is the forefinger? The other forefinger which is bended is showing which direction? It is showing in clockwise, means from west to east. That's why the direction is from west to east. Got it? Or else if you have to find it by Fleming's right hand thumb rule, means what you will do, this middle finger will state as the induced current which is produced. Forefinger will say you the magnetic field which is produced by the conductor, and thumb says the motion of conductor which is produced by the conductor. Okay, so here motion of the conductor is thumb. So thumb is in downward direction, right, falling downwards, and this is the magnetic field in the horizontal component, and this is the induced current. So how, where it is going? Inside, right? So it will comes under west to east. Okay, suppose similarly if they will ask you that same wire, this wire A to B is a wire, AB is the wire. If they will ask you that which end of the wire will have higher potential, then what you will say? A will have the higher potential. How A will have the higher potential? Because the wire is coming downward, right? The wire was in the motion, and when it was in motion, it was coming downwards. So when the wire was coming downwards from west to east direction, which have the higher potential? The A component, the A end of the component will have the higher potential than B. A end of the component will have always with the A end of the component of the wire will always have higher potential than B. And what will be the direction of that? What will be the direction of that EMF? The direction of that induced current, the direction of that induced current produced by that electromagnetic induction will be from west to east. And how we will find it? We can find it by Lenz's law, or else by Fleming's right hand thumb rule. Fleming's right hand thumb rule means middle finger will tell you the induced current, this will tell you, the forefinger will tell you the magnetic field, and thumb will tell you the motion of conductor. That's it. Thank you.